this is Miles Gilston, Vice President of Data and AI for Apps Associates. Welcome to the second in a series of 6 videos talking about Apps Associates' 6 pillars of sustainable AI success. Today we'll be talking about Pillar 2, Data Foundations and Governance. Today I'm pleased to have with me John Schmotlak. He's the Chief Strategy Officer at Apps Associates, and we'll be talking about data and AI. Welcome, John.
Thanks, Miles. Great to be here with you again. Glad to continue the conversation. Absolutely. So I have some questions prepared for you. I figured we can just get started and jump right in there. The first question that I have is that everybody talks about AI being only as good as the data that's associated with it. But what does that actually mean in practice? And why do so many organizations underestimate how much data work is required to make AI function?
Yeah, that's great. I mean, AI really does start with data. And first, let's define data. So by data, we mean both structured data, the kind of data you might have in your ERP or your CRM system, as well as unstructured data. And the unstructured data is really powerful in the days of AI. It's one of the benefits of AI is making use of 70% of the data that people say is unstructured. And if you think about it in your own company, as soon as you start talking about a use case, the first question that'll naturally come up is, what data do we need? Do we have that data? Where is that data? Is it good? Is it accurate? Is it complete? So it all starts with data. And the thing is, for most companies, they've never used their data for AI before. There's no real track record of using data for AI. And let's face it, AI is unforgiving with your data. And it's not explicit. It's almost like passive-aggressive AI. It's not going to tell you it's wrong. It's going to let you get all the way down the line, get a wrong answer, and you won't even really know that you gave it either incomplete or inaccurate data. In a rare case, it might call it out, hey, you're missing something. But generally speaking, it's going to go. The other thing, I think most people are aware of this, but when we talk about particularly large language models, those large language models don't know anything about your company's private data. It was trained on the public internet. So there's really no idea. Even if you're creating a predictive model, that's really, you're creating that from scratch. So let me give you an example. Most people have heard of retrieval augmented generation. Maybe not most people, but a lot of people. It's got a weird acronym called RAG. But what that's all about is making use of that unstructured data, making use of the thousands of contracts you have with customers or suppliers. Now, what you need to do is create a knowledge base. And then once you type your question in, it's going to go over and consult your own private knowledge base before it sends the prompt to the large language model. And then the large language model will infer and reason over your private data. But what people don't realize is it really matters how you put that data in the knowledge base. You have to carve it up. They call it chunking. It's a weird word, but you have to carve it up. And there's a way to carve it up that makes the results better. You also have to tag your unstructured data. You should say what the file name is, the client or the project or the supplier that it's for. And you should give it other attributes. And why should you do that? Because when you go to the knowledge base to do your similarity search, you don't want it to have to search over a massive corpora of data. You want it to search for really just what you've asked. And if you've tagged your unstructured data, your results are going to be better. And you know what? You're going to spend a lot less money because you're not going to be eating up tokens, searching 6,000 PDFs. You're really just focusing on the ones that matter. So, that's an example of preparing your data. And it's only as good as your data that most people, don't really think about. I think mostly they think about their transactional data. I'll leave you for this question. I'm going to leave you with a quote. It's a great quote. I'm not going to take credit. I don't know actually who said it, but they said AI is getting people to do what BI could not. BI being business intelligence, and that is pay attention to your data.
Wow, those are great points, Miles, and definitely things to think about, as you're entering into a journey like that. A follow-up question on that is that when most people think about AI and data, they think about those historical data sets for training the models, right? But you've talked about AI needing a much broader definition of data. What are you seeing in agentic AI in particular?
Exactly, yeah. So agentic AI is emerging as what I would call one of the most powerful implementations of AI. Now, agentic AI is not really a different kind of AI. It doesn't bring anything new to the table, but agentic AI puts together a workflow that frankly could include virtually every type of AI, predictive AI, generative AI, that retrieval augmented generation example. It will tie it all together. And when you create an agent, the agent is making decisions. You give the agents a set of tools, kind of like giving it a toolbox, and the agent's going to execute and make decisions, which is pretty much what it differentiates from automated workflows we've had forever. So how is that agent going to make decisions? On what basis would it make a decision as to which route to take, to use this API, to use this tool? Well, it needs data to make those decisions. So I just said that folks haven't really used their data for AI. That's even more true when it comes to agentic AI, because you're taking what maybe a human did, or part system, part human, and you're asking an agent to do it. So now data doesn't just become your transactional data or unstructured data. Now your master data becomes tremendously important. Maybe you have a filter based on product or region. Now you have to think of data as business rules. Most people don't think of business rules as data. But if you're going to start embedding business rules in agents, and they're using those business rules to make decisions, you have to think of that as data. You have to version it. You have to make sure it's accurate. And this is another example where AI is unforgiving. A human will say, oh, I know that hierarchy's out of date. So-and-so in the other department hasn't updated it. I'm not paying attention to that. I know what to do. AI is not going to do that. They're going to do what your data tells them to do. So you really have to broaden your thought of what you think about data as you begin to build agents to execute what humans used to do. Now, it is true, especially in the early days, most agents will have a human in the loop. But I think if you ask most companies, that's not the end goal. The end goal is not to have humans in the loop 100% of the time. Certainly, there are tasks that can be executed, certainly if they pass a certain threshold of confidence, in a fully autonomous way. And others, may have humans in the loop for quite some time. But yeah, agentic AI is super powerful, but boy, you have to have good data.
So you've emphasized a couple things. You've emphasized the data catalog, and then you've also emphasized the concept of making data AI ready. And I think this is particularly applicable to unstructured data. Can you explain what that looks like in practice and why this is kind of an ongoing activity and not a one-time project?
Sure. So the data catalog we are now viewing as not optional. And I think for a while people thought of the data catalog as being optional. And the reason is that it goes back to, the first question we talked about, where is my data? And when I say where, I literally mean where. Is it tucked away in source systems? Is it over in object storage over here? Is it on some shared server? Is it in SharePoint? Where is the data that we need? Who owns it? What does the data represent? What is the quality of that data? How often is it updated? If you don't understand your data state, it's hard to turn AI into a repeatable process. And that's really what is required to truly transform with AI. So the data catalog gives you visibility into your entire data state, your structured data, your unstructured data, and everything in between. Now, the data platform is really about being able to access the data and to give you an environment where you can do the preparation that you need to do to use that data. I was just talking with a client the other day about a use case, and it was concluded that, well, they didn't really have a data platform, and the data required was pockmarked kind of all over the place. And there was going to need to be some preparation to that data. Some of that data is going to have to be mapped to common values because it's due to acquisitions and the like. They use different indicators for customers and suppliers and that kind of thing. And there was no place where the data was coming together. Now, you may have heard the terms data warehouse, of course, has been around for a while, a data lakehouse. Data lake is still relevant because all of your unstructured data, even something as simple as categorizing your unstructured data, having a folder for contracts with suppliers versus contracts with, just organizing your unstructured data puts you in a better position if you can go and label it and give it tags. you're even further along with your unstructured data. But, I mentioned this idea of repeatability. Our thing at Apps Associates, we've got 6 pillars of sustainable AI success. As much as we like to help our clients get a quick win, we know that that's really not success over the long term, and that's our interest with our clients. So what we're really talking about is repeatability and putting yourself in a position where you can do things more quickly. And having the data catalog and the data platform and beginning to get your house in order, particularly with your unstructured data, because it's probably not. Why would it be? Unstructured data is probably all over the place. You have to kind of get your house in order for that.
It makes very much sense, Miles. So my last question is really around what I hear from customers when they talk about AI, like kind of their end goal, right? Is they want that natural language query, right? And natural language query is just asking a question in English, in plain English, and trying to get a response out of that. That's kind of their end goal, regardless of how much work it takes for them to get from point A to point B, right? Um, what's your thoughts on like how successful that is with clients? Why is it hard to get that right? And what do you need to do? What are some of the gotchas that you need to be aware of in order to make that end goal a reality?
Sure, absolutely. And this is kind of near and dear to me because part of my job, occasionally I'll have to do a demo of an analytics system. And, I feel like I give a disclaimer. I'm talking for all the people here that ever have to do that. It's not nearly as easy as it looks to get accurate answers. Now, you may have seen a demo where somebody put in a question and they got an answer and you thought, "Ooh, wow, that's really good." And I'm just here to tell you, there's plenty of stories where they've rolled out a natural language query and they were just getting wrong answers, but confidently wrong. We all have used AI. We know it's confidently wrong. 2 aspects of AI, confidence and the ability to move on. I think that's all humans should take that. Be confident and move on when you're wrong. That's what AI does. So when it comes to natural language query, and by the way, I'm talking about natural language query over structured relational data. If you're doing natural language query on a PDF or something, you're using similarity search, it's different. But where it really matters, finance, supply chain, procurement, HCM, the answers have to be accurate. And if you think about it, let's just say you said, show me product profitability for product ABC in the Southeast region for all the mid-market customers. Now, how would the LLM know what mid-market customers are? How would it know what profitability is? Is that gross margin? Is that contribution margin? What should be included from a revenue, from an expense standpoint? Is your product catalog up to date? Maybe you have multiple different products with the same name. So the LLM does not know that. And that's why it's so hard. And when you see a demo, somebody has done a lot of preparation in order to make natural language query work. And the price of an inaccurate answer in finance, you can't afford that. So there are some techniques, and I'll give you 3 techniques that are used virtually across all the vendors. Number 1, you reduce the surface area over which the large language model has to do reason and inferencing. So you don't ask it to review your entire ERP database. It's simply too much. So before you even start, maybe you select a domain, accounts payable, accounts receivable, or you have a workbook, an analytics workbook that's devoted to a domain. So first of all, you reduce the surface area, and then even within that, we'll do some things technically behind the scenes to get rid of extraneous columns in the tables or the views, because it confuses the LLM. And then we have to give the LLM context. Like I said, it doesn't know mid-market customers or product profitability. So how do you give the LLM context? Well, what is emerging is semantic models. Now, I don't know if everyone knows what that is, but a semantic model is just a definitional layer, a logical layer, where you establish relationships among tables, you define your metrics, you identify the hierarchies that you want to use. So it's a lovely logical layer that is now proving tremendously useful for these natural language queries. And then the third one, and this is where people kind of chuckle because is literally telling the LLM, we call it metadata or giving it synonyms. You basically go in to the semantic model or the database and you tell the LLM, when you see the word profitability, I want you to use this metric. And maybe that metric is in the semantic model, and now it knows what to do. When you see mid-market, that is a node on this hierarchy. I want you to go over to this hierarchy table, and so on and so forth. So believe it or not, you can just tell the LLM. Now, it's a one-time deal, but it works over and over again, and it allows you to give your end users a reasonable experience, or one that they can trust. And if you talk to your colleagues, everyone's got a story where they trusted AI, particularly in a natural language query, and it didn't work out well, and unfortunately, maybe they stopped using it. You don't have to stop using it, but there are some things you need to do to safely use natural language query over your relational data.
So what I'm hearing, Miles, is that there's no magic wand. There's a lot of work that goes into making AI work for you, right? So
you couldn't have said it better. That is so true.
Yeah. Very insightful, Miles. I appreciate it. I've learned a lot about the importance of that data preparation step in the use of AI. Appreciate your insights, and thank you so much for your time today.
Excellent. Thank you, John. Enjoyed it.